All right, these are notes from section 5.4, integrals of e to the x. So we're going to look at exponential rule for base e. Now the integral of e to the u du is simply going to be e to the u plus c. If we recall, the derivative for e to the u is simply just e to the u times u prime. So the derivative of e to the x is the unique thing about the exponential function base e is that the derivative is itself. So if the derivative is itself, then the integral of the resulting derivative will give us the same antiderivative on the way back as well. Okay, so this is the most convenient rule for us to remember with base e. Let's look at example 1. Integral of e to the 3x plus 1. Okay, so we look to see if we can match this up with the rule for e to the u. So it should be pretty apparent that the u value is going to be 3x plus 1. So let u value be 3x plus 1. Find the derivative. Solve for dx, which is du over 3. Make our substitution. Integral of e to the u times du over 3. Pull the 1/3 out. So now we have 1/3 times the integral of e to the u du. Now e to the u du, we have a rule specifically for that, which is simply going to remain as e to the u plus c. So 1/3 times e to the u plus c. Note that the original function and its antiderivative change, and because that's the rule, and then replace u back in terms. So 1/3 e to the 3x plus 1 plus c. Okay, number 2, we want to match the appropriate u value. So we see we have a rule for e to the sine x. We can think this is e to the u. So if we let the u value be sine of x, we can think ahead and know that our derivative, which is cosine, should cancel out this remaining term that's sitting here. So we let the u value be the exponent, sine of x. Derivative is cosine of x. Solve for dx, du over cosine x. Make our substitutions. Exponent gets replaced with u. Dx gets replaced with du over cosine. The cosines cancel out conveniently, leaving us with the indefinite integral of e to the u du. And integral of e to the u is simply e to the u plus c. And then replace our u back in terms of x. All right, number 3. Integral of e to the x over 2 plus e to the x. As it stands, we don't have a rule for e to the x over 2 plus e to the x. And we can't split this up into individual fractions because we have too many terms in the denominator. So let's look at u substitution. Okay, what if we let the u value be the entire denominator? Then if we think about e to the x, its derivative, which is also e to the x, should cancel out with this numerator term e to the x. So we let the u value be 2 plus e to the x. Derivative, 2 goes to 0. E to the x stays as e to the x. Solve for dx. Dx is du over e to the 3x. Sorry, e to the x. E to the x stays. When we make our substitution, the denominator gets replaced with u. Dx gets replaced with du over e to the x. The e to the x cancels out. We're left with integral of 1 over u. We have a rule for that, which is natural log of absolute value of u plus c. And now replace our u back in terms of x, which is 2 plus e to the x plus c. Okay. Let's look at the second page of notes, number 4. Okay, so number 4, we have integral of e to the x, cosine of e to the x. We have a rule for cosine of u du. So what if we let the u value be e to the x? So if we let u value be e to the x, our derivative will remain e to the x. Our dx is du over e to the x. We make our substitutions. E to the x stays initially. U gets we replace u in for e to the x inside the cosine. Now notice that our u value is, we're trying to go after this e to the x. So we don't want to replace this e to the x with u, because if we do that, we'll be left with integral of u times cosine of u times du over e to the x. So not only does this e to the x have nothing to cancel out, we don't have a rule for u times cosine of u. So it does take a little bit of foresight for us to kind of see what we want to replace and which ones we want to cancel out. So in this case, this outside e to the x does not get replaced. Only this term inside the cosine gets replaced. So we want the e to the x to cancel out. They do. Integral of cosine of u. We know the integral for cosine is simply sine. So then sine of u plus c, and then u gets replaced in terms of x. Sine e to the x plus c. All right, number 5. Integral of e to the 2x over 1 plus e to the 2x. So we can't split up into individual terms. We look to see maybe the denominator will be the entire u value. So let's try that. U is equal to 1 plus e to the 2x. Derivative, 1 goes to 0. The derivative for e to the u is e to the u times u prime. So we have to go through chain rule here. So e to the u times u prime, 2x, the derivative for 2x is 2. So we're left with d over dx is equal to 2e to the 2x. Cross multiply, solve for dx, which is du over 2e to the 2x. We make our substitution. E to the 2x stays. Denominator gets replaced with u. Dx gets replaced with du over 2e to the 2x. E to the 2x cancels out. Coefficient is 2 in the denominator. We pull that out as 1/2. 1/2 times the integral of 1 over u. We have a rule for 1 over u, which is natural log of the absolute value of u plus c. And then replace u back in terms of x. So our final general antiderivative solution is 1/2 natural log of the absolute value of 1 plus e to the 2x. All right, finally, example 6. We can't split this up into individual terms. We don't have a rule for this complex problem. But again, we look at the denominator as our first choice for our u value. Okay, so u is e to the x plus e to the negative x. Our derivative, remember for e to the u is simply e to the u times u prime. So e to the x times derivative of x, which is 1. So I just left that out. E to the negative x becomes e to the negative x times the derivative of negative x, which is negative 1. So if we clean this up, we're left with du over dx equals x minus e to the negative x. I just pulled this negative in front. Okay, solve for dx, which is du over e to the x minus e to the negative x. Make our substitution. Our initial numerator stays. Denominator gets replaced with u. Dx gets replaced with du over e to the x minus e to the negative x. Notice that initially the numerator and what we replace in for dx does not cancel out. But if we can factor out a 2, then we can get the parentheses to match up with the entire denominator. So these will cancel out, leaving us with 2 as a coefficient. So we're left with something clean that we can apply. We have a rule for. 2 times the indefinite integral of 1 over u times du. Integral of 1 over u is simply natural log of the absolute value of u. We keep the 2. And now u gets replaced in terms of x, which is our initial assignment. So 2 natural log of the absolute value of e to the x plus e to the negative x plus c.